Dear students, we will continue with our chapter 2, Solutions. Now let's recall what a solution is. When a solute is dissolved in a solvent, we get a solution. That is, solute plus solvent gives solution. Example, NaCl plus water gives NaCl solution. In NaCl solution, the component that is present in the lower quantity, that is called the solute. So NaCl is the solute, and the component that is present in larger quantity, that is water, is the solvent. So thus we get the NaCl solution. Next we will move on to the concept of solubility. It is defined as the maximum amount of the substance that can be dissolved in a specified amount of the solvent at a specific temperature. Solubility depends on certain factors. First, it depends on the nature of the solute. Next, it depends on the nature of the solvent, then temperature, and then pressure. Next, we move on to the solubility of a solid in a liquid. Every solid does not dissolve in a given liquid. Polar solute dissolves in polar solvents. For example, NaCl dissolves in water. NaCl is an ionic compound, so it exists as Na plus and Cl minus. It will dissolve in water, which again is another polar solvent, that is water H2O. It exists as H plus and OH minus. Likewise is sugar. Sugar is also polar, so it gets dissolved in water, which is a polar solvent. So polar solute dissolves in polar solvents. Non-polar solutes, it dissolves in non-polar solvents. Example, naphthalene and anthracene, both of them are organic compounds. They dissolve in benzene, which is again another organic compound. So all these are non-polar solutes. So non-polar solute dissolve in non-polar solvent. Here naphthalene and anthracene, they are non-polar solutes, and it is dissolving in benzene, so benzene is the non-polar solvent. A solute dissolves in a solvent if the intermolecular interactions are similar. Only, that is, if the intermolecular interactions are similar, then only a solute will dissolve in a particular solvent. For example, NaCl solution. NaCl is dissolving in water, that is NaCl exists as Na plus and Cl minus, and it dissolves in water, which again is polar, so that is it is existing as H plus and OH minus. So there is a similar intermolecular interaction between the solute and the solvent in NaCl solution. So whenever a solute is dissolving in a solvent, the intermolecular interactions will be similar. So we can sum up like this: like dissolves like. That is, polar solute dissolves in polar solvent, and non-polar solute dissolves in non-polar solvents. Next, we move on to another concept, that is dissolution. When a solid solute is added to a solvent, some of the solute dissolves and its concentration increases in the solution. This process is known as dissolution. For example, when NaCl is added to water, the concentration, the NaCl, some of the NaCl particles, it get dissolved in water, that is the concentration of NaCl increases in the solution, and that process is known as dissolution. Next we will see what is crystallization. Some of the solute particles in the solution, it collides with the solid solute particles and they get separated out of the solution. This process is known as crystallization, and at this process a dynamic equilibrium is reached. That is, solute plus solvent reversibly gives solution. That is, the number of the solute particles going into the solution is equal to the number of solute particles separating out. This process is known as crystallization. Next we will see what a saturated solution is. A solution in which no more solute can be dissolved at the same temperature and pressure is called a saturated solution. A saturated solution contains maximum amount of the solute dissolved in a given amount of the solvent. That is, in a saturated solution, there will be maximum amount of the solute. Furthermore, solute cannot be dissolved in a saturated solution. Such a solution is called a saturated solution. Next we move on to unsaturated solution. A solution in which more and more solute can be dissolved at the same temperature is called an unsaturated solution. So an unsaturated solution, it can accommodate more and more solute particles, and so such a solution we call it as an unsaturated solution. And finally, we can see what a supersaturated solution is. A solution which contains more solute than would be necessary to saturate it at a given temperature is called a supersaturated solution. That is, in a supersaturated solution, it contains more solute than a saturated solution. Saturated solution contains maximum amount of the solute, and more than that, further more solute is added into this solution, and such a solution which contains more solute than it would be necessary to saturate it at a given temperature is called a supersaturated solution. Next, we will see the effect of temperature on the solubility of a solid in a liquid. So, solubility of a solid in a liquid, it is significantly affected by temperature. If the dissolution process is endothermic, what do you mean by endothermic reaction? Heat absorbing reaction. If the dissolution process is endothermic, the delta H, that is enthalpy of the reaction, will be greater than 0. Then solubility increases with the increase in temperature. So if the dissolution process is endothermic, then the enthalpy of the solution will be greater than 0. Then solubility increases with the increase in temperature. If the dissolution process is exothermic means heat liberating reaction. It is liberating out the heat energy. In that case, delta H, or the enthalpy of the solution, will be less than 0. Then solubility decreases with the increase in temperature. So this is very important. If the dissolution is endothermic, solubility increases with the increase in temperature. If the dissolution is exothermic, the solubility decreases with the increase in temperature. Next, we move on to the effect of pressure on the solubility of a solid in a liquid. See, you know solids are incompressible. We can't compress a solid. So pressure does not have any significant effect on the solubility of a solid in a liquid. Next, we move on to the next concept, that is the solubility of a gas in a liquid. So we have finished the solubility of a solid in a liquid and the conditions affecting the solubility of the solid in the liquid. Next, we are moving on to the solubility of a gas in a liquid. Solubility of a gas in a liquid, it is greatly affected by temperature as well as pressure. Effect of pressure. First, we will see the effect of pressure on the solubility of a gas in a liquid. The solubility of a gas in a liquid increases with the increase in pressure. You know, gas, it is highly compressible. So as we increase the pressure, the solubility of a gas in a liquid increases with the increase in pressure. Henry was the first to give a quantitative relation between pressure and the solubility of a gas in a solvent. So he stated a law, and that law is known as Henry's law. Henry's law states that partial pressure of a gas in vapor phase is proportional to the mole fraction of the gas in the solution. It is expressed as partial pressure is denoted with the letter P and mole fraction is denoted with the letter chi. So we can read it as P is directly proportional to chi. Wherever proportionality sign is there, it is replaced by a constant. So we can write it like this. P is equal to Kh into chi, where Kh is called the Henry's law constant. Now the graphical representation of Henry's law.